Because of the density of these bays in this area, we expect to see situations where multiple bays overlap. That was identified very early on, even by Douglas Johnson, that the bays overlap, and quite often there's actually no rim development at all between those two overlaps. There's two bays here that are clearly overlapped. They're on the outside. You don't really see a rim here in where they do intersect. However, you can see, and quite often we do get this little dimpling in here where they do come together. So it's pretty obvious that this is two oval overlays mapping into the middle. And if we zoom in on it, there's really no indication on the ground that that's occurring. And we'll just move over to this one here. Until I take the folder of these overlays that I've just created and process them through our programs, the identification of these bays as an overlay is not terribly important. You'll maybe notice the names over there on the side are all exactly the same because I'm just copying and pasting them. When I do process them later, they will gain their own name based on the latitude and longitude. We do notice this getting a very good fit for the smaller bays. As we move upscale in the bays, there's usually a rotational difference in the larger bays from the smaller bays. We're comfortable with that. We feel it's a side effect of the emplacement process in the rotation of the Earth. That skewing is going to be accentuated in the larger bays. On the smaller bays, that skewing isn't as important. And that actually does continue up as we move from smaller to larger bays. Although these two here are pretty much the same, you'd probably have to go to a much larger bay in order to see it. This one actually, I'm going to twist this back a little bit. And then we move in, and you can again see here in the satellite imagery that typically the terrain does follow, and the land use does follow these bays. And as it has historically been known, at least these larger bays. The smaller ones, they get farmed over, and sometimes all you have left is that little subtle rim effect. But we can see these three bays here actually have different land use, even though they're quite small. So we'll go try to capture them. I may actually have to rotate back down again. Still a pretty good fit. Again, quite satisfying for myself as the worker here to see how well these overlays can map in. We know the size has historically been recognized as quite variable between the bays. Some researchers have noted that although the bays are oval and seem to have the same design, that they are actually quite different. At least they used to say that before the LiDARs, because again, as you move in here into the ground with just satellite view, you can see an awful lot of differences between the shadowing here and the way the rim is actually run around. So it would be easy to take a look at these bays and say that this bay actually has a orientation that's quite a bit different than the one that's presented in the actual basin provided by the LiDAR. So with the advent of LiDAR, those researchers who maintain that the bays aren't all exactly the same plan form, I use the term plan form to describe the shape here, are, just simply aren't dealing with the reality that they are. As our survey continues across different regions of the country, we do see this plan form change slightly. And again, we suspect that's due to the difference in the arrival velocities at the angles are coming here as the subject is deposited. and as these bubbles are formed and burst, that's going to be different at higher latitudes and shorter distances to the impact versus lower latitudes and or longer, further distances from the impact. So each of those does create a slightly different plan form. The one we're using here right now, you can see it up here, is called Bay Prototype.png, is pretty much the generic plan form we're using. And that covers probably the overwhelming majority of the number of bays in Virginia and North and South Carolina.